Today I'm going to talk about the three types of bonding that we've been looking at and kind of compare them next to each other. We've talked about them individually, but I think it might be helpful to kind of sum up and talk about them all together. So I've got a chart here. We're going to compare ionic, covalent, and metallic bonds. Now the first thing I want to talk about is the things that they have in common, and there's really not a lot except the reason that they form. And so all the way across here, the reason that these bonds form is to reach lower potential energy. So I'm going to say they form to reach lower potential energy. And so that is across the board. That's the only reason atoms get together in the first place. They want to lower their overall potential energy. And after that, there are really more differences than similarities. So for ionic, if you remember, we said that the electrons are transferred from one to another. And so one atom gives up electrons to become a positive ion. The other atom will accept electrons to become a negative ion. And it's the attraction of the positive and negative that holds that type of bond together. With covalent, they share electrons. But they share those electrons only between two atoms, which is different from metallic, because metallic also share electrons, but they're sharing among many atoms. And so we have that sea of electrons kind of model. So share electrons among many atoms. There's also a difference in the types of elements that form these different types of bonds. So most of the time an ionic bond is going to form between a metal, which ends up with the positive charge, and a nonmetal, which ends up with the negative charge. And on the periodic table, remember the metals are on the left, nonmetals are in that upper right corner, separated by the stair-step line. Covalent bonds generally are going to form between nonmetals. And of course, metallic bonds involve metals. And the reason for this really is not necessarily because of what types of atoms these are in the first place, metals versus nonmetals. It's really because of the electronegativity values. And so we have ionic bonds forming because we have very different electronegativity values. One is going to be highly electronegative, that will be the nonmetal, and one's going to be only slightly electronegative, that's going to be the metal. We'll get into that just a little bit more when we talk about polarity. Written down here. For covalent, they're going to have similar values for electronegativity. I'm going to abbreviate that EN now. But they're both going to be high. So nonmetals have high electronegativities, even though they're not very different. Both of them are going to have a lot of attraction for that electron. Metals also have similar electronegativity values, but in this case, they're both going to be fairly low, and that's going to result in these other characteristics that they have. All right, structure. For ionic, if you remember, we have that crystal lattice structure where there are lots of attractions for all of the ions for each other. It's not just a one-directional type of bond. For covalent, we have individual particles, individual molecules, and the attraction is very specific between two atoms, one for the other. And then with metallic, we haven't really talked about the structure of that. We call those also metallic crystals, where you do have lots of attractions, because remember, you've got that sea of electrons that attract all the way around, all of those little positive ions that have formed. Strength. of these bonds. We haven't talked much about that, so I wanted to include a little about that. For ionic and covalent bonds, these are both strong bonds. Sometimes ionic is stronger than covalent. Sometimes the covalent bond might be stronger than a particular ionic bond. But I bring this up here just to point out that metallic are very weak bonds. So the ionic and covalent are particularly strong types of bonds, but not so much for the metallic. Now, all of these things, especially the way the electrons are treated and the structure of the substances, leads to some unique properties for each of these. So again, this is ionic, this is covalent, and this is metallic. And so we've talked about a couple of things, but again, I think it's just helpful to maybe summarize here. We talked about conductivity. And so, as you know, metals are very conductive. So they're good conductors. Things with covalent bonds are always very poor conductors. And that's because they don't have these particles that are free to move. We said that metals are good conductors because the electrons, that sea of electrons, give you a chance for those electrons to move around a lot. Ionic, if you remember what we said about those, they are poor conductors when they're solids because those charged particles are just locked in place in that crystal lattice. But they're good conductors if we melt them or dissolve them because that frees up those charged particles to move. Ionic substances are very brittle because, again, those ions are locked into place. There's only one way that they'll go together because of those positive and negative interactions. And the same is true for covalent when they're solids. They're also very brittle. Think about something like an ice cube. It's not going to bend. It's going to break if you hit it with a hammer. But again, metals, because of those mobile electrons, are very flexible. And the last thing we want to talk about here is melting and boiling points. We mentioned those before, but just to review. So ionic have very high melting and boiling points because there are so many attractions all around an individual ion. In order to overcome those attractions, it just takes lots of energy. And the same is true for metallic. There are lots of attractions, lots of interactions, and so overall, metals have high melting and boiling points. There are a couple of exceptions like mercury, but overall fairly high, especially compared to covalent. These guys usually don't have a lot of attraction of one particle for another, so these have low melting points and boiling points. So again, that's just a little summary of the characteristics of the three types of bonds that we've talked about. I hope that was helpful to kind of pull it all together.